Welcome to another edition of Planetary Radio Live. I'm Matt Kaplan of the Planetary Society. We are here to celebrate the arrival of a human-made emissary at another world. In less than an hour and a half, MAven will go into orbit around Mars if one last critical firing of its rocket engine goes exactly as planned. We'll turn to NASA TV in less than an hour for its coverage of that burn. Till then, we've got three terrific guests of our own who will be talking about how this spacecraft will unveil more closely held secrets of the red planet. We'll also examine our ever-expanding knowledge of Mars, with most of that knowledge gained through the robots that we've sent there. And we'll hear about some of those other robots as well. Later this evening, we'll enjoy a live virtual visit with the Planetary Society's CEO, Bill Nye the Science Guy. Let's bring up the first of our in-person guests. She is the Planetary Society's senior editor, but we like to call her our planetary evangelist. You may have seen her outstanding, fully illustrated blog at planetary.org, or perhaps you're one of the nearly 45,000 who follow her planetary science reporting on Twitter. She's also a contributing editor to Sky and Telescope magazine, and she joins me every week here on Planetary Radio. Please welcome geologist and planetary scientist Emily Lakdawalla.
Thank you, Matt.
Emily, the one thing I left out there was your growing popularity as a public spokesperson for space science. This stuff seems to be catching on.
I think so, and I certainly enjoy exercising my title of planetary evangelist, telling the whole world about everything that's going on across our solar system.
Well, thanks for being here tonight, and we'll be hearing much more from Emily as the evening proceeds. Next up to join us on stage is yet another weekly contributor to the radio show. You hear his voice shaking the universe each week with a random space fact, although we'll turn to our audience for that help tonight. He tells us what's up in the night sky, what happened this week in space history, and he and I challenge you with the Space Trivia Contest. I know it's hard to believe that he could find time after all of that, but he's also the Planetary Society's very busy Director of Science and Technology with responsibility for our many projects around and above our world. Please help me welcome astronomer and planetary scientist, Dr. Bruce Betts. Welcome, Bruce.
Thank you, Matt.
It's a little bit off topic, but I thought maybe instead of waiting for what's up, can you tell us maybe, is there an update on what's happening with our little Bennu project, or projects now?
Yes, you can. We are partnering with the OSIRIS-REx asteroid sample return that will be launching in 2016, and we're collecting names for the next week or so. Your deadline is September 30th of anyone who wants to send their name to an asteroid and back, and also stay in space on the carrier spacecraft. And so go to planetary.org/Bennu and fly to an asteroid. It'll be cool.
Once again, the deadline for that?
September 30th, 2014.
So not much time left, especially for those of you who are hearing this show on the radio. You know, it could be a week after we record this. And I should say that it is Sunday, September 21st, at a little bit after 6 o'clock in the evening here on the Pacific coast of the United States. That's important because, as I said, we're going to be following this next climactic moment in the MAven mission as we proceed through tonight's program. Our third and very special guest is not one of my co-workers at the Planetary Society, but he has joined us here for previous Planetary Radio live shows. Dr. Richard Zurek is Chief Scientist for the Mars Program Office at the nearby Jet Propulsion Laboratory, where he has worked for 38 years. He's also the longtime project scientist for the Mars Reconnaissance Orbiter, still circling Mars with the sharpest eye in that sky after 8.5 very revealing years. Rich studies the upper atmospheres of both Earth and Mars, so you shouldn't be too surprised to learn that he's on the MAven science team as well. Please welcome back to Planetary Radio, Rich Zurek. And Rich, we're going to get your microphone in place there. Thanks very much for joining us this evening.
Happy to be here.
I noticed in your bio that you once worked, a long time ago, for another lab that is largely responsible for this newest arrival at Mars.
Yes, after I got my degree in atmospheric science, I was at the University of Colorado, their laboratory for atmospheric and space physics. That organization will be operating the science data and analyzing that data from the MAven spacecraft. Bruce Tukoski, the PI of this mission, is at LASP.
And the PI, as we've heard many times about other missions, that's really the go-to person for a mission, right?
Particularly on these Mars Scout missions. This was the second mission selected like this, the Phoenix mission being the first. The PI, science guy, is in charge of those small missions. And yet, it's a very long and complicated process to get there. Bruce was thinking about his proposal more than a decade ago. Had to compete with other ideas that were good.
Bruce Tukoski.
Bruce Tukoski.
Sorry. How do you know that other Bruce Tukoski?
Well, that other Bruce was a graduate student at Caltech, and we worked together when I first came to JPL on the Viking mission.
What is your role in this mission, as if you didn't have enough other stuff to do?
Well, there are 8 science instruments that are on board MAven, but there was a group of us who wanted to try something that we had tried with previous missions when they were aerobraking at Mars, flying the spacecraft into the atmosphere. When you do that, the atmosphere slows down the spacecraft, and you can get an estimate of how thick that atmosphere is. We're going to do that on MAven. We're going to use the spacecraft as the instrument. As it dips down into the atmosphere, as it's at its closest approach to the planet, then we're going to see what the density is, and we can compare that to the other instruments that are measuring the composition.
Since we have started, let's talk a little bit more about MAven, this spacecraft, which hopefully will be sticking around Mars for quite a while, beginning tonight. It is the Mars Atmosphere and Volatile Evolution Mission. You knew that had to be an acronym, right? One of those NASA acronyms. Rich, you're going to tell us in a couple of minutes about the science of this mission. But first, let's talk about the spacecraft itself. And we've got a nice picture of MAven and her instruments that I think we can throw up on the big screen here at the Crawford Family Forum here in Pasadena. And Bruce, tell us a little bit about what people are looking at there, and you can see it on this bottom monitor down here.
Sure. So this is the whole spacecraft that's with the solar panels on the side edges and the main bus, the main part of the spacecraft in the center there. And each of those arrows is pointing at least one of the science instruments that Rich mentioned, most of them focusing on things all looking to get at the main questions that MAven's looking for, which is what happened to the Mars atmosphere? So we have a very, very thin atmosphere now on Mars. There is a lot of evidence of liquid water, running water in the past, but liquid water is not stable on Mars now because the atmosphere is so thin. And so, in a nutshell, what happened? Where'd the carbon dioxide go? Where'd the water go? So they look at the particles and what they can detect is leaving the Mars atmosphere now. They look at the solar wind, the solar charged particles from the sun coming in to Mars that would knock off parts of the atmosphere. And then they piece that with information about the atmosphere, the thicker upper atmosphere itself. And in the whole thing is get an idea of what's happening now at Mars and then figure out an extrapolation of how you can go back and try to figure out what happened to the Mars atmosphere. I would like to turn it over to Rich, who is far more well-versed in these things, and maybe you can tell us a little bit more about the instruments. Let me give one lead-in, though, that ties into what you're talking about with your experiment using the whole spacecraft. I take it the reason that those solar arrays, generally all other Mars spacecraft have solar arrays that are completely flat. They're in one plane. It's a little hard to tell from this image, but these have a gull wing shape, and I take it there's a reason for that.
There is indeed. I said that the spacecraft comes into the atmosphere. It comes down where it's about 90 miles above the surface at its closest approach. It's a very elliptical orbit. It then flies out of the atmosphere, comes back, and once it's in its science orbit, it will do that every 4.5 hours. By having this kind of gull-winged shape, when it goes into the atmosphere, it's like keeping it stable. It's like the badminton so that you can keep, as it flies, the shuttlecock will keep that design, will keep it stable as it flies through the atmosphere.
So anyway, now you can go on to those other
Well,
pesky science instruments.
You claimed, Rich, a few minutes before we started, that you could name every one of those instruments. Tell us what they do. There's a Planetary Radio T-shirt in this for you, if you can do that right now.
Oh my, because I only know the acronyms, but let's try. Okay, you see a couple of names that are called SWEA and SWEA. That's for looking at the solar wind. Where's the energy that will drive particles, molecules out of the Mars atmosphere? It's coming from the sun. And it comes either as energetic particles or by radiation. And so these instruments are meant to measure that. SWEA is looking at the electrons, and the one with the I in its name is looking at the ions. Now, there are other particles in different energy ranges, and that's the Solar Energetic Particle Instrument, which is down there on the bottom of the spacecraft. You also see that there's, at both ends of the solar arrays, magnetometers, and that's because we want to see how that solar wind is interacting with that small remnant field of magnetism that is on Mars. As we'll talk about later, that magnetic field, where it was there, how strong it is, and when the global field might have gone away is critical to understanding what happened to Mars volatiles. Now, the other instruments that are on here are also the Langmuir probes, which are also trying to detect energetic particles. They will also be able to detect small dust particles, and that's important because just 4 weeks after MAven gets to Mars, there's a comet that's going to come close by at about 140,000 kilometers. So that's close, 90,000 miles. And this will be a chance for us to understand what that field looks like. Finally, you notice there's something that sticks down from this spacecraft. That's an articulated pointing platform, and it carries 3 instruments on it. One of them is measuring those ions and molecules that are energetic just because they've absorbed solar ultraviolet radiation. The others are looking, imaging in the ultraviolet at the atmosphere, looking at the composition of the atmosphere, including its temperature, mostly in the upper atmosphere, but also down into what we would call the middle atmosphere. And finally, there's something that's looking at the mass of the molecules and such to tell what is in this composition, what kind of molecules are there, and how is that distributed over height. And they measure it as the spacecraft flies in and then flies out. During 5 week-long campaigns during the 1 Earth year of the MAven mission, MAven will fly even lower, about another 25 kilometers down into the atmosphere, and that will get to the well-mixed part of the atmosphere, and there we'll get a chance to see how things separate as they get to altitude. So there's a brief rundown of all of these, but as I said, my instrument's that whole spacecraft.
Well done. What size shirt do you wear?
So if I could interrupt here for a moment, I have you may see I'm sitting here with my laptop monitoring Twitter and finding out what's going on with the spacecraft. I see somebody at the Canberra Deep Space Network Station, which is the one in Australia, gigantic dishes are now listening in on all the spacecraft, has reported that we've just had the scheduled loss of signal from the MAven spacecraft as it switches from its high-gain dish antenna, which does the high bit rate, high rate transmissions to Earth, to its low-gain antenna. And it has to do that because it's beginning to get ready to turn for the burn to enter Mars orbit. So it's happening, guys.
And this is all automated. This is all sequenced. There are no commands coming from Earth from this, right?
Absolutely not. It's all automated because there's a 12.5-minute delay between us and Mars. So all the time this evening that we say that things are happening right now, they actually already happened 12 minutes ago. And there's nothing we can do about it if we find out that something went wrong. So just cross your fingers.
I was going to go to you next, Emily, because we got another slide here that we can switch to, which is, it's called the mission architecture. And it's interesting because Rich was also saying about this one, telling us that really it's not much different than you would see from any other mission that's going to Mars.
Absolutely. It's a pretty straightforward trip to Mars. You have to just launch from Earth at exactly the right moment that you can get onto this elliptical orbit that when you happen to reach Mars's distance from the sun, lo and behold, Mars is right there. You only get that opportunity about 1 in every 26 months. And once in a while, we have a mission under construction that doesn't quite catch the bus. and it misses, and they have to wait for more than 2 years in order to get that next opportunity. That most recently happened with Curiosity. But it did not happen with MAven. They're made their window, they got on the way to Mars, and they do this fairly quick transfer, and the name of the orbit, Hohmann Transfer Orbit. I was looking at Mr. Random Space Fact over here, trying to remember it. And it's a pretty straightforward trip, and pretty much all Mars missions follow the same path, including another one that's going to be arriving in Mars orbit just 2 days from now. It's called Mars Orbiter Mission. They do abbreviate that to MOM, but I cannot bring myself to call it MOM, so I continue to call it Mars Orbiter Mission. And that is India's first deep space mission, India's first mission beyond Earth
Pretty
orbit.
cool. Let's hear it for India. And we're going to hear from Emily in just a few minutes about the whole flotilla, the army of spacecraft that are now at Mars, telling us a lot about this mysterious planet. And, you know, a question that is related to that, which I think I can ask at this point, is, and Rich, I'll start with you. Why orbiters at all? I mean, there must be people wondering. Obviously, we now know how to put these wonderful spacecraft down with wheels on the planet or in some interesting spot, as Phoenix did up in the northern hemisphere, up near the Arctic, the Martian Arctic. What can we do from orbit that we can't do from the ground?
Well, the first question is, where would you put them? And that's what our orbiters can do. They show us the whole planet. They show us where the interesting areas are, where we have the highest potential of further scientific discovery on the planet. They also help us understand the hazards that those landers might encounter as they go down onto the surface. The other point is think about this. Suppose you had just half a dozen samples of the Earth's surface. Would you know the Earth? No. So we have to put these things into context. The landers give us the ground truth, let us know that what we see from orbit is really there. But we do know, because the landers can show us at even greater scale, even finer scale on the planet, that we don't see everything from orbit. So the combination of the two, that's what gives us our biggest strength.
Plus, of course, your wonderful high-rise camera on the Mars Reconnaissance Orbiter gives us those nice shots of Curiosity and Opportunity waving up there waving from the surface, those rovers.
They can rove, they can't hide.
I just want to quickly mention the other partners in this mission, like the Goddard Space Flight Center. You heard about LASP at the University of Colorado, Boulder. Goddard Space Flight Center manages the mission, getting there anyway, and provided 2 of the instruments. Lockheed Martin built MAven and is responsible for mission operations. Space Science Lab at UC Berkeley provided 4 more of the instruments. And your place, JPL, is doing the navigation and deep space network and that Electra telecommunications relay hardware, which is another big piece of this mission, which is not really about Mars science, right?
It's a program where all of the missions help out one another, either by finding a landing site that's interesting to go to, and with the Electra package, by relaying data back. So you get a lot more science data if the rover can conserve its power and just send its information a few hundred miles up into space to an orbiter that then can relay it back to the Earth, a communication satellite at the planet. And that's what those Electra packages do on MAven. They will provide that capability for future missions.
Emily, I won't ask Rich about his spacecraft MRO getting a little creaky after 8.5 years there in space. But that's part of what this is about, right? We need somebody new up there to be the telephone operator.
That's right, because the spacecraft that we have up there right now doing the relay, they're getting a little long in the tooth. It's not just MRO. The oldest one up there and one of the workhorses for relay is Mars Odyssey, which is just 1 month shy of its 13th year in Mars orbit. It's survived a long time. And, we're kind of living on borrowed time with Odyssey. We've had a few safe modes, a few scary moments, and one of these days we're going to wake up and it's not going to be there anymore, but we'll be very happy for all of the work that Odyssey has done. And in fact, they're not done doing science with the spacecraft. They're teaching that old spacecraft new tricks. They're shifting its orbit from one that used to look at the sunlit Martian surface in the late afternoon to one that will now begin to look at the sunlit Martian surface in the very early morning and see what happens on Mars at dawn. There's going to be, fog in some places, which is kind of exciting. So it'll be a different mission, but we'll still be capable of doing all of the relay that it does for the landed assets. I'll interrupt my update to remark that at Canberra, they've just remarked that they have lock on the low-gain antenna, so they're now in communication actively with the MAven spacecraft as it barrels in for its Mars orbit insertion.
Excellent. All right, so we're so far so good. Rich, I said we would be able to talk, or you'd be able to tell us a little bit about the science behind this mission. Let's do that now. This, still very mysterious history of Mars and how it went from being that warm and wet place to the cold desert that it is today.
When our spacecraft, when Mariner 9 became the first orbiter around another planet, it saw an amazing thing. It saw channels carved on the surface of this planet. It saw things that looked like valley networks. It saw streamlined islands on the floor of big canyons and such. And what that meant was water must have flowed on the surface of Mars. Where's that water today? If you were to pour liquid water out on the surface today, it either boils away into the atmosphere or it freezes. So the two possibilities, sort of expanding on that, are it's frozen in the surface or that water has escaped to space. Now, why would that happen? Because it hasn't happened on the Earth, right? We still have our oceans and such. Well, early Mars had a global magnetic field that probably stood off the solar wind, kept it from sweeping through the atmosphere and removing those molecules from the planet. That global magnetic field, we know it was there because we see parts of the surface that were magnetized by it, and very strongly so. But that was early in the planet's history. Some point, billions of years ago, that changed. That global magnetic field, for whatever reason, we're still trying to understand that, went away, leaving it and permitting the solar wind to sweep in to the atmosphere. And since that time, it's been able to strip away the molecules. Water gets broken up into its component molecules. The hydrogen, being the lightest gas, goes to the top of the atmosphere and is more readily removed. And so today's result is we see a planet in which the atmosphere is thin, and because it's thin, it's cold, and the water is either there as ice on the surface, as a vapor in the atmosphere, or perhaps in the subsurface as ice again. So if we go to the video, we have an example of how this process of the solar wind stripping things away operates. This is a model simulation for Mars, and what you see here in the colors, the red colors are the densest parts of the atmosphere, and you can see that the arrows, which represent the solar wind directions, are stripping away the molecules in a very turbulent kind of fashion. In this simulation, this has been happening for millions, hundreds of millions, a billion years or more. And that can remove quite a bit of mass. How much? That's what MAven is trying to figure out. Because that's not a simple process, that stripping away. There's energy that's absorbed, the ultraviolet radiation from the sun that heats up the atmosphere, and the molecules are bouncing around and flying out into space fast enough to escape. Other charged particles are coming in, and by exchanging their charge with the molecules, other ions, can excite other modes of stripping away of that atmosphere. What we want to do is understand the process today, because we can quantify that. We can see which of these processes is most important, driven by the solar wind that we see today. Now, why is that important? Let's go to the next slide here. What's the driver? It's the sun, and we want to look at this process today. The solar wind's not a steady, even thing. It's changing all the time itself. In fact, there's an 11-year cycle that we all know about, I think, and MAven is going to be there during a period when there are solar storms. And in fact, we've seen a couple of really big ones just recently in which it looks like the solar activity is picking up just in time for us to see the imprint of that on the atmosphere of Mars. So in the next slide, we're going to talk about why can't we just observe what's here today, multiply by a few billion years, and we've got our answer. Well, unfortunately, the sun has been changing over those billions of years too. In fact, early on in Mars history, when that water was down on the surface as a liquid, in that early part of the history, the sun, total irradiance, was less, maybe by a quarter of what it is today, and yet it was a UV bright star. So the spectrum of radiation counts too, because the ultraviolet ones are absorbed high up, and that drives this process more. So we're going to try to extrapolate that back, and then we're going to try to measure what the response is, not just today, but also by looking at the isotopes in the atmosphere, and that gives us a clue over time, the integrated effect of these drivers. So, in a very brief few slides, that's what the MAven mission is about. Understand that escape process, understand where that ancient water on Mars might have gone.
Dave McKeever, who is our technical director in the back there, is it easy to run that video one more time, that visualization, Dave? Because I've got a question for Rich about that. That's a lot of work to put together a model, a visualization like that. Somebody deserves some credit for that.
This is an investigator from Nagoya University in Japan who's been associated and has been doing these kinds of calculations to make predictions of where MAven should look. And you'll notice that there are things that are happening close to the planet and far out from the planet. And that's why MAven is in that elliptical, very egg-shaped orbit. It's so it can sample the solar wind as it approaches the planet and then look at the response and the interaction close in the parts of the atmosphere where the molecules may be escaping.
When we look at a visualization like this, the data that this represents, if you were to show a video like this to Mars scientists, atmospheric scientists of, let's say, 40 years ago, when we were just beginning to learn more about Mars with robotic spacecraft, they probably would have thought this was someone's fantasy, right? I mean, this is really incredibly impressive.
You couldn't have made such a video 40 years ago because you didn't have the computing power to do that. And you wouldn't have had the memory to be able to store the information and then to visualize it this way. These kinds of simulations are what we hope will enable us to extrapolate back into the past and understand what happened on early Mars. And it's because of the computing power and that technology advance that we can do this, that we have a hope of doing this.
Dave, thanks for pulling that video up again for us, because it just is, I don't know, we just watch that the rest of the night, I think. It's pretty cool. Better than most of the stuff that's premiering on the new TV season this week. Emily, I said we would want to get to you to put MAven in context. Talk about all of these wonderful robots that are serving us up on Mars.
Well, it's a long list. I've already talked a little bit about Mars Odyssey. There's another spacecraft that's been there for 11 years in orbit, which is European Space Agency's Mars Express. And that, too, has been taking tremendous photographs all over Mars, and they continue to do that. There is Mars Reconnaissance Orbiter, as we've already mentioned, taking all of its sharp-eyed photos with the HiRISE camera. But there's a second camera on Mars Reconnaissance Orbiter that doesn't get mentioned nearly often enough. It's called the Context camera. And its resolution is not as high as HiRISE. It can't spot a rover on the surface, but it has imaged the entire planet at 6-meter resolution in these gargantuan, absolutely enormous images that let you see huge swaths of the landscape. It's absolutely spectacular. And so those are the orbiters that are currently in orbit. I'm cheating on my iPad right now because I can't even remember all of the digits in the number of days that Opportunity has operated on Mars. Today is Sol 3,790 for Opportunity. And most recently, Opportunity has climbed a place called Dowyak Ridge, looking for some interesting rock formations in a high mountain. Opportunity for so long has been a desert sailing rover, just kind of tootling along a flat landscape from dune to dune. And all of a sudden, it's a mountain climber. She's taken over from her sister Spirit from being a mountain climbing rover and is now up on these ridges, climbing all over the place, looking for the same exact kind of clay minerals that brought Mars Science Laboratory Curiosity to the surface of Gale Crater. Curiosity is now in its Sol 756. They just made a big announcement last week that they have finally arrived at Mount Sharp. Now, those of you who have been looking at Curiosity's images might be a little surprised to hear that we've arrived at the mountain, because the mountain is actually still kind of off in the distance on the horizon. What's happening is that the mountain is made of layer upon layer upon layer upon layer of sediments, and Curiosity has reached the very bottommost layer of sediments. And one of the first things you learn in geology is something called the principle of superposition. Superposition means one thing on top of each other. The principle of superposition is that whatever's on top of a stack of things has to be the youngest thing. Whatever's on the bottom of the stack of things is the oldest thing. So now that Curiosity is at the bottom of the stack, Curiosity is at the oldest rocks she is ever going to see on her entire mission to Mars, and is exploring the ancientest Mars history we have ever visited with a spacecraft. So that's very exciting. It's so exciting that the rover drivers wanted to get right to drilling, so they actually were going to try to drill this weekend. I don't know if they've been successful or not, but to put the drill bit down and make the very first touch into that Martian rock at Pahrump Hills.
Maybe Rich can tell. Did you have to rein them in?
Oh, no. Let them go, because we're at the good part. This is where you see that rock record of the history of Mars, and it's extending back to the very early times, a time where it's very hard to find those rocks on the Earth.
And we only can see them on Mars with the help of our Mars orbiters that have sharper and sharper vision and have been able to identify these most ancient rocks. Because one thing about them being on the bottom is that you can only find them if you have a spot that's dug very deeply into the surface. And Gale Crater is one of the deepest holes on Mars. And so it's a place that we were able to go to find these ancient rocks. There's one last Mars mission that I haven't mentioned because it's not yet at Mars. That's Mars Orbiter mission. They are doing a very important test of their main engine in about 6 or 7 hours. They haven't turned on that engine in 300 days, and hopefully it will work, because if it doesn't, they may not make it into Mars orbit. But they actually do have a plan B if the main engine doesn't work. So we're crossing our fingers that they will successfully arrive pretty soon, too.
And of course, India has never done anything like this before.
No, every day that spacecraft operates in deep space is farther for India than they have ever reached before. So it's really quite amazing. They have kind of a mixed science payload on their spacecraft, but the thing that I'm most excited about is a wide-angle camera that can take photos of all of Mars at once in a beautiful 2,000 pixel square color imager. So that's going to be a spectacular data product if they can regularly take these beautiful pictures of the entire globe of Mars. We don't really have a spacecraft that can do that at Mars right now. All their vision is so sharp, they see like postage stamps. And this spacecraft will be able to take big, wide views. I keep on hitting the microphone. Big, wide views of the surface of Mars, and that's going to be really thrilling.
Yeah, I was thinking about the poor context camera, which has really delivered so much great data, so many wonderful images. And we think of it as, you know, the poor sister of HiRISE, because it only has a 6-meter resolution, right? That's crazy, isn't it?
It is indeed. And it has covered most of the planet. And to give you a contrast, HiRISE, with its much higher resolution, has only covered 2% of the planet. And so every time we take a HiRISE image, we take a context image so that we can see where that postage stamp is in the broader context, thus its name.
Yeah. Well-named camera. Bruce, there
Yeah,
have
Matt.
there have been so many other missions that we've just heard about stand on the shoulders of. It's been a pretty steady progression, hasn't it?
In recent times, it's been a steady progression. There was a burst starting in '64 with Mariner 4 with the flyby, and starting in terms of successful missions, and then you had a burst of missions going through through Viking. But once the Viking 2 orbiters and 2 landers faded away, then you had a pretty big gap, although there was the little-known Phobos 88 mission from the Russians that had 2 months of orbit that some really odd people did PhD thesis based upon. But there's no good reason to do that unless there's no other Mars mission. And then we started with the success of Mars Global Surveyor in '97-ish, and now we've got almost pretty much every 26 months, every launch opportunity for the last many launch opportunities, we've had progressions, and this will be your preview. Random space fact.
Ah, good. A little precursor there.
Is if these 2 missions successfully go into orbit around Mars, MAven and MOM, then you will have the most active missions at Mars ever. At 7.
So I hate to say it, I should knock on some wood, but it does seem like the recent record has been so good that maybe, sorry, Rich, that the Mars curse maybe has been
when you're
broken.
forcing scientists to start knocking on wood, stop.
But I mean, it's hard. It's still incredibly hard to get
Yes,
out there, whether you're landing or going into orbit.
Yeah, and the long-term history of Mars exploration is a lot of splatters on the surface and a lot of failed missions and orbiters. It's hard. It's really hard, and NASA in particular and ESA with Mars Express have been really impressive in recent opportunities, but it's still an awfully, deep space is hard. And when you start doing things like going into orbit and doing crazy things like intentionally dipping your spacecraft into the atmosphere to satisfy some crazy scientist,
right.
then you're like, well, maybe it's too easy. We're just putting an orbiter around Mars. We'll do something challenging.
Emily.
Actually, a couple things. MAven will not be the only spacecraft doing aerobraking maneuvers. There's another spacecraft doing aerobraking maneuvers, but not at Mars, and that spacecraft is Venus Express, which is at the end of its long mission at Venus. And what do you do with a really old spacecraft when you're done with your science? Well, you just start dipping it into the atmosphere and see how it does. And I'm being flippant about that. But, we do aerobraking for more than one reason. We do it to learn about the atmosphere, but we also can do it because it's a free way to decelerate your spacecraft once you arrive at Mars. And NASA has done that several times successfully with Mars spacecraft, but the European Space Agency has not yet done that intentionally because they do not have experience doing it intentionally. And with Venus Express at Venus at the end of its mission, intentionally dipping the spacecraft lower and lower into the atmosphere, they're going to get the practice they need to be able to apply that at other planets, including Mars. But the other thing I wanted to bring up was that we haven't all just seen spacecraft splat at Mars. We've seen splats in other locations too. And I was reading about Curiosity the other day, and it scared me. Even though Curiosity launched successfully 3 years ago, it scared me to read that they had a 3.3% chance of launch accident on that mission. We're so lucky that we just can ignore a 1 in 30 chance of launch accident, but that will ruin your whole day if that happens.
Well, we're coming up on that very critical moment here. We in fact will be going to NASA TV in just about 5 minutes just to check in as that Burn by MAven gets underway. This is Planetary Radio Live. We are at the Crawford Family Forum in Pasadena, California with our special guests, Emily Lakdawala and Bruce Betts of the Planetary Society and Rich Jurek of JPL and the Mars Reconnaissance Orbiter, and the guy who is going to be just thrilled when MAven dips down into the atmosphere to see what happens. And Venus Express, for those of you listening to the radio, or if you want to know more about that, we had a recent show on Planetary Radio talking to an ESA scientist about that great spacecraft, which is just about out of gas. So they feel, why not fool around a little bit? Because at some point pretty soon it's going to be on empty.
Make it sound like they're doing donuts. Hey, let's burn rubber in the parking lot. We're almost out of gas.
Sounds good to me.
Well, according to the timeline, the MAven spacecraft should now have rotated into the correct orientation to perform its Mars orbit insertion burn, which is coming up in about 9 minutes.
Emily, you're writing a book about Curiosity.
I am writing a book about Curiosity. And it's going okay. Curiosity is a very large, very complex mission, and nobody I talk to seems to understand the whole thing. So apparently it's my job to try to understand the whole thing and put it into book form.
And this is sort of a serious, all-encompassing story of the mission?
That's right. I decided I was inspired by David Macaulay's How It Works books, and I want to explain everything about how this spacecraft works, both the science and the engineering. My thought is that I'll try to explain the science to the engineers, and I'll try to explain the engineering to the scientists and see how things go.
Very cool. We're close enough now. I think we probably could go ahead and go to that NASA TV feed, which actually began about 12 minutes ago as we are speaking here in Pasadena. And I could not find on the NASA TV website where they're originating this broadcast from, whether it's coming from the NASA studios at NASA HQ in Washington, or whether, well, no, it looks like they are, is this at LASP or at Lockheed Martin?
This is at Lockheed Martin.
Okay, very good.
Mission support area.
And as we said, Lockheed Martin, which built the spacecraft, is also in charge of the spacecraft at this time because they are handling the operations, getting it to Mars. Rich, do you know, is Lockheed going to stay involved, or will LASP at the University of Colorado pretty much be taking over control of the spacecraft?
No, Lockheed will still continue to support operations of the spacecraft, providing the engineering support that's needed to fly this mission safely during its period there. So there's a transition of the people that will be doing that, and Lockheed has sort of pioneered a mission support concept in which their teams are supporting a number of spacecraft, including Odyssey and the Mars Reconnaissance Orbiter.
And you know what's interesting looking at this scene, it's remarkably similar to one we've seen many times from your place right up the road, JPL, still, I think it's safe to say the leader in planetary exploration. But we tend to forget that these things are happening elsewhere, like also APL in Maryland.
That's right. This MAven is Goddard's first planetary mission. They, of course, have done many missions for the Earth and for the Moon, but this is their first deep space mission. So this is a new step for them. There is a backup facility that at Goddard, which is active right now in case something should happen at Lockheed and such, that could take over if needed.
Emily, do you have an update?
Yes, Canberra has now confirmed that the turn to burn attitude is complete. They are ready for their orbit insertion burn.
Okay, which starts in about 5 minutes as we speak. Dave McKeever, I'm going to ask you, go ahead and bring up the audio, or is it up? Hopefully they are actually talking right now.
Copy, thank you again.
Oh, just in time for a little station break, apparently. A little tune. All right, we'll continue here instead and return to NASA TV in just a few moments. Oh, look, it's a random space fact.
Yay!
Didn't we copyright that? Isn't that trademarked?
Didn't use that term, did they?
I would think so. Anyway, this is NASA TV, which we will be coming back to, and we'll check back with them. I gotta think that in about 5 minutes, they will have some folks talking as that burn begins. Remember what we were told, that this is all happening. Everything that we hear happening in supposedly real time is actually 12 and a half minutes ago out there near Mars. We hope to go into orbit about Mars or around Mars.
The burn is 33 minutes long. So unlike the landers, where it's actually over by the time you get the information back, they should be able to have some contact with the spacecraft as the propulsive system is breaking the satellite into orbit.
Well, look at the nice set they've put together there. Let's bring the audio back up because it looks like they're talking to us.
You're such a media guy.
Look at
that nice set.
From the project MAven team here at in Littleton. He's going to help us translate some of the real-time operations for us.
Sure. During this event, the data rates are so low
How low
that
are they?
really the only thing we have is the signal from the spacecraft that the radio generates, and then the navigation team knows what that frequency should be, but because the spacecraft is moving, we get a Doppler effect. The navigation team is able to measure that Doppler effect, and that is going to be the keynote speaker tonight. Not only the subsystem engineers that are concerned about their specific subsystem, but the navigation engineers, all of us will be watching that Doppler plot tonight because that's the most direct information that we're going to have. The spacecraft at the moment has completed its slew to the burn vector and is waiting for this flight software to command the engines to start.
How long are those engines supposed to fire? Is this a long event, or are they just for a short period? I mean, just kind of give us an idea of what's expected.
It's about a half an hour. 33 minutes is what is expected, but from my perspective, that is going to be a very long 33 minutes, yes.
33 minutes
what
of
if
terror.
I mean, right now I'm looking here and it says time to burn start. Is that accurate? That's saying about 3 minutes, 50 seconds we've got still.
That's why my knees are moving. I'm getting excited, and I think we all will in just a few moments. But as I said, the spacecraft, she's ready. She's been ready. She's been committed. There's 12 minutes of light time between us and her. So we can't reach out and give her a helping hand any longer. We're 3 minutes from the start of the burn, and it takes us 12 minutes just to talk to her.
So
One of the
just
things that they
explain
do
this
right
just
at the
for our
beginning
viewers.
of the
We all know
burn
what
is
light
they'll
years
do a
are, and these are
settling
light
burn
minutes.
30
What
seconds
does that
before to
mean?
make sure
It's
that all of
12
the
and a half
fuel is
minutes
at the
of
right
light
end of the
time
tank to
to light.
start the rest of the burn.
And while we've got the sound down, do any of the three of you know who's talking to us right now?
That's Tim Preiser, is at the board there, the Lockheed engineer.
Okay.
He's been involved in many of the other missions, including
She's
MRO.
committed.
Let's keep it down still for another moment. They talked about using Doppler to tell us what's going on with the spacecraft. Bruce, that's pretty common too, isn't it? What are we talking about here?
Yes, so Doppler shift is the thing that makes sound alter if you have a speeding train going by you or a car going.
The one that goes by the forum here.
Yeah,
every 5
exactly.
minutes,
When you
yeah.
hear the metro train and the frequency shifts as it's coming, frequency shifts up. As it goes away, it's shifting down. The same thing happens with light. What they'll be looking at is the radio transmissions from the spacecraft. And by looking at the Doppler shift, it gives you an idea of what you know the frequency that you sent, the wavelength that you sent the radio beacon at, and then you look at its change, and that gives you an idea of velocity. And you can get an idea, hopefully you see a velocity change when you ignite your burn.
And when you stop burning. that rocket
Ideally,
engine,
yeah.
right?
Yeah. And hopefully it doesn't go to zero.
And I said up front that this has to be done exactly right. But Rich, I've also read that maybe not. Maybe if the burn ends less than 5 minutes early, if for some reason the burn is interrupted, we may still achieve orbit. It just won't be the orbit that we were hoping for.
This burn is designed to put it into a 35-hour orbit. If the burn is not as energetic as they're expecting here, then it would be a longer period, but hopefully still a capture orbit. This mission also has a restart capability on its burn here. That is, if for some reason the spacecraft were to detect that there's a problem, normally it would go into something we call safe mode. We don't want it to do that now. We want it to finish the burn. And so they've activated an algorithm on board that will do a rapid exit back and get back into the burn and try to finish it. Now, there's a big difference in the amount of fuel that would be used. And if it doesn't have to do that extra burn, if everything works nominally, they should have enough fuel to be able to extend the mission for several years after that.
Emily?
Well, I think we should bring up the audio because it should be coming.
Sure, let's do that. We should be right on top of the burn.
We're within a 30 seconds, so
We're getting there. So how are you feeling?
you just, I can't contain myself anymore. We're going to watch the magic, the technological wizardry that teams like this routinely perform. It's just staggering to me.
Now, this is a simulation, clearly, but
No, that's an
there's
actual
no
camera
cameras
shot.
flying by next to MAven, so we're simulating, but it's based on real telemetry information and fact.
Getting close.
Yes, this simulation is following the same timeline that's on board.
Oh,
So if you were on board, or if you were traveling next to MAven, you would see the engines have just started.
so the mission clock is saying, are we in a
That's a
deceleration
simulation.
burn? What's going on?
The burn has started. From now, the burn will be complete, and we will be captured. We will have transitioned from a heliocentric orbit to a Mars captured orbit.
Very good. I don't know if we can be able to pull up this Doppler chart, but can you explain what's going on? We've got this Doppler chart.
Right.
Here we go. Tell us what's going on. I assume this is right there where we are in time.
Correct. So hopefully the folks that have joined us tonight can see this. The burn has started, and that is this green set of dots.
And I don't know if
I hear
the
applause.
listeners can hear that. A lot of clapping on. I know we've got the cameras fixed over there. Here's some good clapping, and I think they're telling us.
What we're seeing, right, real time, this dashed line is time now through the burn. So you'll see it march across. The green dots are, and let me just explain, green there are 3 deep space network stations on Earth. There's one in Goldstone, California. It's green, so that's the one that's making these measurements now. We have friends in Canberra, Australia that have been taking measurements for us all the way through, and they're in Madrid, Spain, have been helping. So when they do the station handovers, these colors will change from green to red to blue, but the ones we're watching right now are these green dots.
Okay.
Each dot is a measurement
Thank you.
from Goldstone.
Okay.
And as these dots come in, if they follow this set of dots that have been laid out in front of it as the happy path, I'll call it, that is as theoretical perfect as you can achieve. The navigators know, because of the frequency that the radio on board has, because the spacecraft is moving, that signal encounters a Doppler shift. So the navigators know what that frequency is at the radio. They can measure the Doppler shift, and with that information and some math, This is where science, technology, engineering, and math come together to solve a problem that's very difficult to comprehend. They can take that Doppler shift and they can measure and derive the velocity and be able to track the burn. And if we track right down the middle, then everything is nominal.
Okay.
So right
in the
now,
middle
all the
is
people
nominal?
in mission control are staring
They
at
have to
that
stay
graph
within
with
this.
those lines, looking very closely to make sure that those lines are matching to their prediction. You've never seen so many people stare so hard at a graph as they're doing right now in mission
And it
control.
looked like it was so far anyway pretty much dead on. We'll keep this up for another minute or two, but I do want to tell those of you who are here with us in the Crawford Family Forum that we're almost to the point where you guys are going to get to join the conversation. So have your question ready. If you do want to participate, please do keep your question very short. Raise your hand and somebody will come over with the microphone. We'll do that in a moment, but let's bring that audio back up for just another minute or so.
As MAven maneuvers into Martian orbit.
Thank you.
That's you.
Okay.
That's you, Nancy. So as the spacecraft's getting closer to achieving orbit around Mars, it's important to remember why this effort is so important. Humanity has long pondered about the character of our sibling planet. Because of its similarities to Earth, Mars has always provoked special interest. What's more, we're not the only show that's happening at Mars this week. Just 3 days from now, an Indian spacecraft called MAven, the first for that country, is about to reach Mars for scientific investigations of its own. Everyone at NASA and its partners wishes that team all the best, and especially the MAven team tonight. These folks really are the ones that know what's going through their Indian counterparts' heads right now. They know what they're going through. MAven is all about exploration, and exploration in this case means science. There's nothing in the solar system, or anywhere else for that matter, that exists without being influenced by other objects, and Mars is no exception. Questions about what happened to the Martian atmosphere lead scientists to important questions about how the sun played a role. We're going to spend some time discussing the number of compelling scientific mysteries and how the MAven team intends to pursue those answers. But
Okay,
let's
we
start
could
with
probably
an
take that
overview
down.
of
Now,
the
we've
central
already
question.
explored those compelling
Why was the
Martian
sun's
mysteries.
influence so profoundly different on
So
Mars and on Earth?
we'll return
Here's a
to
closer
NASA
look.
TV, but let's go ahead and go out to the audience here because we have a few minutes before we are joined by yet another very special guest. And I think we already have one question right here, sir. Hi, what's your name?
Name is David from Woodland Hills. Regarding the solar wind stripping off the Martian atmosphere, what are the forces at Earth that has prevented that from happening here?
The Earth has a global magnetic field, and that field is strong enough that it keeps the solar wind from penetrating into the atmosphere as deeply as it can at Mars. And so there's a shock at both of the planets, but that sort of bow shock is much further off, much further distance from the Earth's surface than it is at Mars. The strength of that field is what does that, what keeps it there. So those solar energetic particles, they get trapped in the magnetic field lines, our radiation belts. They produce the auroras in the polar regions because that's where they're directed and inducted. On Mars, they can strip right into the main atmosphere over all the planet.
Do we have another question out here in the audience? I see several hands, actually. There's one there, and we'll come back over here in a moment. How about right here? Hi, what is your name?
My name is Leslie Perg. I wanted to know that it seems like if the what's primarily happened is ablation of the atmosphere, that it would be a unique opportunity to extrapolate backwards to find out also what the initial atmosphere on Earth was like before it was stripped, another line of evidence. So I was wondering if you had an idea of what you were going to be extrapolating back to and what you were hoping to find out about rocky planet evolution, atmospheres in general. Thanks.
Great question. Can I just add to that? Because we do know that Earth's magnetic field does reverse itself
Yes, it
periodically,
does.
and there's a time when, as it's doing that, there's no magnetic field to speak of.
That's correct. That's for a much shorter period of time than has been operating at Mars here. But the real question, in a sense, is why are the two magnetic fields different? And that has to do with the interiors of the planet. And one of the things that we want a future mission that's being built right now called InSight, will land on the planet, put down a seismometer, put down a heat probe that will look for the internal heat of the planet and try to measure that as a way of constraining what the Mars interior looks like today, help us understand why that magnetic field went away on Mars, but didn't on the Earth. Now, there's still a mystery if you look at all the planets. Venus doesn't have a global magnetic field either, and it's about the same size as the Earth. So it's not just a matter of mass. Somehow it's a matter of evolution. What was their early history?
That InSight mission, Bruce, do you have any comment about that? That next lander that's headed to Mars?
Yeah, we've been there have been science hopes to do, just like there have been hopes to do upper atmosphere, exosphere studies that MAven is now the first to really focus on anyway. There's been desire to get a real seismometer, heat flow probes on the surface, a true geophysics mission. And InSight will be the first to do that in an effective way, and we'll be putting down a very sensitive seismometer, having heat flow probes. It's a very focused mission to study that, the geophysics. But on the other hand, where we're used to now on the Earth, having seismographs all over, we use those to not only study things relevant to whether the building's going to shake, but also as a probe of the interior of the Earth, because as you measure those waves propagating through, that's one of the ways we know that part of the Earth's core is molten, is liquid, and so getting any type of insight on that on Mars will be insightful.
Emily?
Yes, I have just want to interrupt with a brief update from Mission Control. They now have telemetry indicating that all 6 of MAven's engines are burning as expected, so we're doing well.
That's great. That deserves a hand. We're getting there, and the telemetry is coming pretty quickly, so I'm very hopeful that before we end this evening, we'll actually know what's happening and whether that spacecraft is joined all those sisters in orbit around Mars. We got a question right here from a young man. Hi, what's your name?
Griffin.
So what's your question?
Is there auroras on Mars?
Is there a what on Mars?
Auroras.
Aurora? Great question.
We think there are, but we haven't seen them yet. And part of that is just because our instruments aren't able to look for them at the sensitivity of what's there. We're actually kind of looking ahead here there's a comet that's flying close by Mars, and it might actually excite auroras that would be stronger and more prevalent than we've seen in the past. Maybe we can detect those.
Emily, you've written about this comet.
Yeah, I have. So there is this comet that's going to be approaching very close to Mars. And for quite a while after the discovery of the comet, I have to say that most Mars mission operators were pretty freaked out about what this comet might do to their precious spacecraft. Now, the rovers were always okay. The worst thing that could happen to the rovers is that they'd have a really pretty light show with a lot of comet dust entering the atmosphere and making a meteorite storm. But the orbiters are a different story because they were not designed to be sandblasted by comet dust. And so there was a lot of scientific research going into figuring out just how much dust was how near this comet at closest approach. The good news is, turns out that the comet is in a good position for most of its dust to avoid sandblasting our spacecraft, which means, hey, yay science, we can do some spectacular science with 4 orbiters positioned to study a comet at its close approach. Mars Reconnaissance Orbiter will actually be able to image the nucleus of the comet. The other spacecraft will be able to take photos of the coma, but MAven is really uniquely positioned to study how a comet interacts with a planet's atmosphere. We have never, ever seen what happens when a comet excites an atmosphere in this way. The closest we ever came to it is when Comet Shoemaker-Levy impacted Jupiter's atmosphere, but we didn't have spacecraft right up on top of the comet, and MAven's going to do some spectacular science. The problem with MAven doing the science is that it's not even supposed to be in its prime science mission yet. They're just turning on the science instruments for the first time. And so it's a little scary, I think, to the engineers to be operating your spacecraft at full tilt before you've checked everything out yet, but they've got a plan in place to do that, and it sounds extremely exciting.
Wasn't there also some effort to make sure that some of the orbiters were, hiding, in a sense, behind Mars?
That's right. At the time when the densest part of the comet gets closest to Mars, and it's still not very dense, the impact probability is still very low, but they've done something called phasing the orbits. They sped the spacecraft up in their orbits by just a tiny fraction of a meter per second a couple of months ago. And what that does is it positions the spacecraft on the backside of Mars, hiding behind Mars at the moment of closest approach of the dust cloud. But the closest approach moment of the dust cloud, the coma, is not the same as the closest approach moment of the nucleus, which means that Mars Reconnaissance Orbiter and a sharp camera is actually going to be in a much better position to take a photograph of the nucleus at closest approach. It's going to be pretty cool.
So it's pretty cool. You got to have suddenly a whole bunch of Mars missions that are comet missions.
Yeah, right. Comet flyby missions, or a comet flew past all these Mars spacecraft is going to be very cool.
I think we're almost ready to bring in nope, not yet, not our next guest. So I'm going to try and reach that special guest, but I think we do have another question out there in the audience. Hi. Yes, sir.
My question's about, as the spacecraft goes into the atmosphere and slows down, I'm assuming on every orbit, what does that do to the lifespan of the mission? And if solar activity makes Mars' atmosphere expand, I'm not sure if that happens or not because of the extra activity. Can you compensate with the engines to sort of bring it up into a higher orbit?
Very small maneuvers adjust how deep into the atmosphere you go. And so in a way, it's not really aiming for a particular altitude, it's particular density. And as long as you fly there, things go pretty much as you expect. So if the atmosphere, for instance, if there were a big dust storm down below, or there were a big solar event that pumped up the atmosphere, they can raise that closest approach a little higher, and then they'll be operating at the same density. They've got margin. Don't worry, they've thought about it.
And I was just texting with really my boss because I think he was slightly delayed, but I think he's going to be able to join us in a moment here. Has the call come through? Nope, not yet. He said, can I wait till 7:05? He must have been late getting back to wherever he's staying in New York City.
Well, he's on the East Coast. Time's a little off there.
Yeah, it's true. They're a lot less precise.
By the way, don't text and host.
Do we? 1 minute? Okay, we'll be ready in a moment here. Emily, you were going to say something?
Yeah, I have a different kind of update on Mars. We just got pictures back from the Curiosity mission showing the drill successfully placed against the surface on Mars.
All right.
Woohoo!
Okay, we'll be digging into that layer pretty quickly here. Yeah? Trying to bring it up here. Up. And there. Let's adjust that audio a little bit. I told you that a special guest would be checking in. He is the Chief Executive Officer of the Planetary Society, but tens of millions have known and loved him ever since he created and hosted a clever little TV show a couple of decades ago. He's pretty much been continuously in the public eye since then through his books, his personal appearances, and several other TV and online series. The next of those books, stay tuned, will be published very soon. He's also heard here on Planetary Radio almost every week. Coming to us live tonight from New York City, please help me welcome our boss at the Planetary Society, Bill Nye the Science Guy. Howdy, Bill.
Greetings.
And we can see and hear
from
you.
New York City, the town so nice they named it twice. We had a big march here in New York City with regard to climate change. Estimates are over 300,000 people.
Wow.
Expressing concern about climate change, and we had a speaker here tonight who works at the Goddard Institute for Space Studies. And we remind us all that climate change was nominally discovered in the modern era by people exploring space, exploring the atmosphere of Venus. And there are lessons to be learned in the volatiles of the atmosphere of Mars.
Big day for SpaceX as well. Another mission on its way, another Dragon capsule on its way to the ISS, the International Space Station.
Apparently it went flawlessly, yes?
So I've heard.
That's great.
Yeah.
It's going to lower the cost of access to space. which will engage more of the citizens of the world in space exploration, which will, in my view, help us know and appreciate our place in the cosmos, which will improve the quality of life for everyone on Earth. Is that such a big deal?
Bill, I heard that the reason you weren't able to join us in Pasadena, other than this wonderful demonstration of public activism, is that you were doing a favor for a friend there, a close friend in New York.
Yes, I hosted Star Talk Radio because Neil deGrasse Tyson, on the board of directors of the Planetary Society, was unavailable. I'm just helping out. I'm just a team player over here.
I don't know. Can you see our other guests here today, your colleagues Emily and Bruce, and our special guest, Rich Zurich? Very good. And a room that's bursting with Mars fanatics.
Great to see everybody. That's good. That's good. Who doesn't love Mars? And we're learning about the Martian atmosphere, which will inform us about our own, I think, ultimately. We learn more about Mars's past, look for signs of water and life. It could change the world.
So what are your thoughts as we now are about 15 minutes, slightly more than that, from, if all goes well, yet another spacecraft beginning to tell us more about Mars?
Well, as I understand it, I mean, you're there with the experts, but we want to learn more about the Martian atmosphere, and we have this extraordinary scheme of taking an elliptical orbit and scooping, dragging our way through the atmosphere a few times, a year from now or so, or some period of time hence after we check the spacecraft out. And this is another example of a very reasonably priced mission that's going to make discoveries that really are yet unknown. I mean, learning about Mars's past will inform us about the history of the Earth and the history of the solar system, which for me is part of getting at those two big questions that I'm always fascinated with. Where did we come from? Where did we come from? How did we get here? How old is the solar system? What are we all doing here? And then the next logical question is, are we alone? What if some remarkable amount of methane is found in the Martian atmosphere? My, oh my.
To say nothing of remarkable technological advancements that I bet are in large part responsible for your being able to look into your handheld device there and talk to us from backstage somewhere in Brooklyn.
Yeah, it's remarkable. And I'm on a wireless network here at a theater, and I found the sound quality is a lot better when I use this earpiece, which is connected to the phone and to you by radio waves, which pass through vacuums and through the air, as if by magic. But of course, it's not magic, Matt. It's science.
I think Emily has an update for us.
Speaking of radio waves, because radio waves are not instantaneous, they take the speed of light to cross space. MAven has, we hope, entered orbit at Mars now, but we won't know for another 12 and a half minutes.
Okay.
That is amazing. So let me ask a deep philosophical question while you're all there and we're waiting for the next signal, 12 and a half minutes hence. Is it that it's already happened on Mars, or is it that this event on Mars doesn't happen here for 12 and a half minutes after it happens on Mars?
Bill, this is why I'm a geologist. I said, Bill, this is why I'm a geologist, not a theoretical physicist. I like things that I can touch and pick up and throw, and it'll land on the ground, and don't ask me to talk about this other stuff.
While I, on the other hand, love the relativistic characteristics of this question.
But it's an interesting question.
Rich, what's your view?
I think we're deep enough into the time here that MAven should have captured, but it may not yet be in the orbit desired. The burn has to finish 33 minutes.
Hey, let me ask a technical question about a relativistic one. How significant, how many adjustments do you have to make to take into account special and general relativity when you're trying to do a mission like this? Let's say in percentage. You have classical physics, and then you have relativistic physics. How much does it play? How much does it play into it?
That's a great question for a JPL person, because JPL is responsible for the navigation of this mission.
And if I were on the navigation team, I might be able to answer that.
Bruce, do you have any idea?
Not much. That's a technical term, but
didn't they teach you relativity at that place?
But Dr. Betts, Dr. Betts,
I'll give the same answer.
Would you agree that not much is infinitely more than zero?
Why, yes, I would.
I mean, the fact is they now
So
have
it
to
had to be
account
taken into account.
I was going to say that they have to account for solar light pressure, for solar sailing on solar panels in spacecraft
yeah.
now. So I'm
They
quite
do?
certain they account for relativistic effects as well.
And wasn't this, I mean, we used to talk, we can still talk at the Planetary Society about the so-called Pioneer anomaly, and didn't that turn out to be something related to light pressure? Bruce Betts?
It was actually aliens.
Just
No,
gentle pushes.
it wasn't. Yes, it was. This was the Pioneer spacecraft headed out of the solar system, showed an anomalous deceleration. They weren't. They were slowing down a little more than expected, and it turns out it's basically due to asymmetric radiation of infrared. The heat being emitted from the spacecraft is doing it more in front than behind, and that radiation pressure essentially is slowing the spacecraft. Just the tiniest little amounts.
Yeah.
But yeah, because you happen to have the radioisotope thermoelectric generators, the RTGs, are warm. They're nuclear sources, and your dish is always pointed at Earth, and they're always basically radiating off the back of that dish, so it ends up making asymmetric. More than you might have wanted to divert, but it's hard to give a short explanation of the Pioneer anomaly.
Bill,
Well,
go ahead.
It's light pressure, but it's below visible light. It's infrared, right?
Yes.
Heat going off the front of the Pioneer spacecraft. Yeah.
Right, exactly.
But there were a few. There was quite a bit of time there when we wondered if there was some mysterious feature of the cosmos that was yet to be discovered.
Right. But
Matt,
this was.
you had a question.
I do. Speaking of solar light pressure, would there happen to be, I don't know, any sort of mission coming up that you might be involved with, which has to do with using that light pressure?
Object, leading the witness.
If we were here, may I play the role of the? Here, I'll do this. That's the judge. The witness may answer the question. Yes, we are. The Planetary Society is building a solar sail spacecraft. We had a day in the life test, and we are very hopeful that we will have a test flight coming up in May, and then we'll have real solar sailing about a year from then. And I got to tell you all, I'm getting older. But in space exploration, a year just isn't that long. It just goes by really fast. You have to meet all these milestones. It has to work when it's vibrated. It has to work when it's hot. It has to work when it's cold. It has to work when it's plugged into the rocket. And it has to work when it's unplugged from the rocket. And it has to get in touch with the ground. And it goes on and on. And so a year goes by really fast. And people have been hustling the last few weeks. And we've solved. And I say we, people, very diligent people who work for the Planetary Society have solved this antenna problem, which has been a real bugaboo for quite a while now. So it's an exciting time at the Planetary Society, and I'm very hopeful that people in the audience will be excited about the solar sail mission, the light sail mission, and it's so shiny. How shiny is it? It's so shiny, we'll be able to see it from the ground with the unaided eye, and I'm very hopeful that we will have a light sail above program similar to the International Space Station above, the ISS above, where we have a system that tells you when it's overhead and you can go running outside and watch it. It's just cool. It's big fun. So here's the thing. When it comes to space exploration, how long did it take us to get to Mars this time? 7 months?
I think more like 10.
Is that right?
10.
10 months.
10 10 months. But we had to use a big rocket and throw millions and millions of dollars at the rocket fuel and so on. But if you can trade time for money, this light sail, the solar sail style ship, can take us to many, many destinations in our solar system at a very, very much reduced cost. So this is where we at the Planetary Society feel we are advancing space science and exploration.
Bill, it's awfully late there. I know you probably want to get to the subway to get back to Manhattan, right?
I guess so. And I'll tell you what, the subway was really crowded. There were 300,000 people right in the middle of downtown New York. The town's so nice, they named it twice. And subways were very, very slow. We had one of the guests on the show here well over an hour late. And I'll tell you, in subway terms, that's a long time.
Yeah.
And so it shows you that space exploration has led to a global awareness of what I like to call our place in space. And having you all there in Pasadena and me here in New York, and we're able to talk about it using my handheld device, is really a tribute to the technology that is a result of the human spirit. So thank you all very much for including me. Thank you all for coming to the forum tonight. And let's keep our fingers crossed for a successful MAven Mars insertion.
Thank you so much, Bill. Thanks for taking a few minutes to do this. Bill will be back on Planetary Radio for his regular segment that we do every week, next week's show, and then I will see you October 1st in Toronto for a celebration of the Canadian space program.
Yes, coming up is this thing that I've attended for many years now, the International Astronautical Congress. Congress is a European expression that means conference. And people from all over the world come and talk about space, and the Planetary Society is going to have, I guess how else to express it, the highest profile role we've ever had at the International Astronautical Congress, and I thank all of our members and supporters for enabling that. And this way we hope to engage people from all over the world in the passion, beauty, and joy of science. And if you're not aware, the Canadian space program is very well celebrated in Canada. This is a Canadian $5 bill that includes a picture of an astronaut. It's hard to say if it's Chris Hadfield or not. And the International Space Station, which, as you may know, the Canadian Space Agency has a very large role on. So we are very excited to be participating in the Astronautical Congress, and thank you all again. Let's change the world.
Thank you, Bill. Good night.
Good night.
Bill Nye, the Science Guy, CEO of the Planetary Society. Sailing away there. We're going to go right back to NASA TV as soon as we can here. There's Dave McKeever needs to finish the work up here in the front to close out that conversation with Bill. But we should be very close now to at least us here on Earth finding out if MAven has successfully gone into orbit around Mars. So in a moment, we'll bring that audio back up. Looks like maybe they're still taking questions. Emily, do you have an update?
I do have an update from Twitter that the burn so far is nominal, which probably means at this point, it's been long enough, it's probably in Mars orbit. It just hasn't necessarily yet reached the orbit that they want to be in.
Okay, because as I had heard, as long as it got within 5 minutes of the end of the planned 33-minute burn, they would be in orbit. It just wouldn't be the orbit that they're looking for.
So we're almost there.
Rich, you have been in this position before. You've actually been there many times, I think in particular of Mars Reconnaissance Orbiter. What kind of stuff is running through your mind as you wait for that magic announcement?
Well, you're just holding your breath because you're waiting to see whether it's all going to work the way you worked for years to have it happen. And some of us have also been veterans of missions for which this didn't happen as we expected. So it's still a dangerous business. It's a harsh environment. You do everything you think of, and then you worry about the things you didn't think of as a matter here. So far, it looks like it's going very well. The mission has been, it launched not only on the first day of its launch window on the Earth, but the literally the first window. That is the first period during the day. It got off successfully. Let's hope it's good luck and its good performance continues here.
Let's go ahead and bring that audio back up on NASA TV and check
MAven
in.
has performed flawlessly since she launched, and she continues to do that today.
Let's just see if we can listen into the flight controllers and see if there's any chatter on the net.
They're probably is anxiously watching that Doppler plot.
Quiet is good, though,
like
right?
We are. Quiet is great.
So there's a lot for the team to track at this stage, from the engine performance to navigation data to the overall health of the vehicle. But there's not a lot they can do right now in these last final minutes, right?
Yeah, they can spectate along with the rest of us and watch with confidence as MAven performs her duty.
Okay. You and I were talking
Emily, are
earlier
you seeing
about
anything?
what this plot meant and the
It's
fact that it's
almost
been
there,
tracking a
but you
little
won't know
bit.
until we see that
Bring our
Doppler
viewers up to speed.
graph curve
Right, so the residuals that
there
we're
it is.
measuring here are, one, very minor, but two, is showing that all of our engines and our center of gravity may have been off by just a little bit. So we have been what I would characterize as a little bit underperforming relative to the predictions. So as we watch this current time go across this plot, we have a band in here where we expected the engines to cut off, and right in the middle would have been the nominal. So we'll see how close she comes to the pin.
So we think we're going to run just a little long beyond that 33 minutes?
Yeah, simple integration
Potentially.
would tell me. If we're underperforming just a bit, then yes, it'll take us just a few more seconds to get there.
So we clearly have just passed that time mark
Yes,
that was predicted.
So this minimum time was what we needed to actually capture. So at this point, we feel pretty confident that we've crossed that line in the sand. The line on the other side is one that would tell us we have burned plenty and we don't want to get any closer at our closest approach. So somewhere in between here, and nominally it should be in the middle, or actually closer to maybe the first one, is where it would have cut off if everything was right down the pipe. Okay, so you can see there is a bit of a residual there. So now we have to integrate our way through there. But as I can see, there are now 3 Doppler measurements that have just changed dramatically from this trend. So
what does that mean?
That means, to me, the engines have been commanded to turn off.
Okay. So the engine may have turned off. Let's know if we can go.
This is MAven Nav on MAven Cord. Based on observed navigation data, congratulations. MAven is now in Mars orbit.
All right.
Okay.
Oh my goodness.
Awesome.
Wow, that just came. You called it. You called it. There it is.
Data doesn't lie.
Now, who was that was just on the net?
That was Dave Folta from Goddard Space Flight Center. He is our chief navigator and has actually been the one that has been calming us as we approached Mars. When it was just a little baseball and now it was a big baseball, he had it all under control.
This is an exciting time. I mean, what are you feeling right now?
I'm about to pop. It's a blender of pride and relief. I can't tell you how proud I am of the little spacecraft and certainly of all the people that worked on her. It's been a long, long journey by a lot of people to get to this point today.
Fantastic. Thank you so much. I think are we gonna be able to just let's listen in on and watch the MSA for just a little bit.
So we'll talk a little bit over this. Emily, I assume you also saw that confirmation on the Twitter feed?
I did. Everybody was all talking about how their feeds were slower than other people's feeds, and that Twitter is really the #1 quickest way to learn about anything happening. I mean, you people here in California, you know that the first way you hear about an earthquake is when you see it on Twitter, and then you might feel it rattling your feet.
Rich, Mars Reconnaissance Orbiter has a shiny new neighbor in orbit around Mars.
That's right. One more member of the family that will fill in a gap that we've had for quite a long time, looking at the upper atmosphere of Mars.
It's good to remember that such a
I think we're there.
mission requires lots of people.
We'll go ahead and take the audio down on NASA TV because we are just about finished with our special coverage of Mars orbital insertion by MAven this evening. There is one more thing that we need to do, but before we do that, I want to thank Rich and Emily for helping us understand MAven and this mission and what it's going to be doing out there at Mars and all the other stuff that's happening out there at Mars that we humans have managed to do at another planet. And really just thank you for being part of this celebration, folks. Rich Zurek is a member of the MAven science team, as you've heard. He's also chief scientist for the Mars Program Office at the Jet Propulsion Laboratory and project scientist for the Mars Reconnaissance Orbiter. And Emily Lakdawala is the Planetary Society's senior editor and planetary evangelist. You'll hear her again next week on Planetary Radio, but I bet you'll be blogging about this too, right, Emily?
This and lots of other missions. It's a very active period in space exploration right now.
All right, and I know you're headed for New York tomorrow morning, so have a good time there.
I will.
Ladies and gentlemen, Emily Lakdawala and Rich Zurek. Okay, I'm going to let the two of you exit, and Bruce, you can stay there, or you can just stay in that seat, I suppose. You've noticed that I didn't say goodbye to Bruce. Why? Because it's time for What's Up, our weekly tour of the night sky, and your chance to win the Space Trivia Contest. Take it, Bruce.
Hey, Matt. It's good to see you.
Yeah, welcome. So glad you could make it.
First, I want to take another opportunity to remind people if they want to send their names, their friends' names, their dogs' names to an asteroid and back, go to planetary.org/Bennu, BENNU, by September 30th. Submit your name, and off you will fly to an asteroid on the OSIRIS-REx mission.
Operators are standing by.
Even better, you don't have to talk to operators. Maybe that's just me. On to the night sky. We've got Mars, surprisingly enough, is up in the night sky, by the way. One of those amazing geometry things. In the MAven coverage, we talked about how Goldstone was communicating with MAven for part of that time. Well, that's because we can see Mars in the sky. So if you go out in the early evening, look in the southwest, you will see a reddish dot that may be Mars, but it's awfully close to the red star Antares, and actually is moving past it over the next week to 2 weeks, and they are actually similar in appearance. And then over to their right is the yellowish Saturn, separating and getting farther and farther apart. In the pre-dawn, you got Jupiter over in the east, looking super bright. Can't miss it if you happen to be conscious in the pre-dawn. We move on to this week.
Which Bruce is not usually. So.
We move on to this week in space history. It's a night thing. I look at things at night. This week in space history, 2007. Been 7 years since the Dawn spacecraft was launched. Just had a little bit of a hiccup, but is successfully cruising along towards its second big asteroidal object headed for Ceres this coming year after exploring Vesta. Now, I'd like the audience help on the count of three. If you can say with me, random space fact. 1, 2, 3.
Random space fact. Very nice. They didn't even get to rehearse that.
That was really good. The MAven spacecraft, you may have heard of it. It is about the length from tip to tip of those solar panels, about the length of a school bus. And it is about the mass of a fully loaded SUV.
That's bigger than I thought.
Well, that's why I throw these facts out for you, Matt. Give you an idea. All right, we move on to the trivia contest. And first, presumably, we will do the last contest.
You have presumed correctly.
All right, excellent. What I asked people, what star has the largest proper motion in the sky? Proper motion being kind of side-to-side motion, angular movement over time relative to the other more distant fixed stars. How'd we do, Matt?
Really well. And this was kind of a tougher one that you asked people.
Why, yes,
actually
it was.
had to research, and we had a very nice turnout for this one.
Good.
Our winner, you let us know if he got this right. If he did, it's Jose Vasconcelos Costa of Natal, Brazil. And he said that the star with the greatest proper motion is Barnard's star. Is he correct?
That is correct. It is Barnard's star, which is actually not a naked eye object, but is an easy telescopic object. And it moves its lateral speed, its sideways relative to our line of sight speed is 90 kilometers per second. What this means is 10.3 seconds of arc is traveled every year, when what that means is roughly in a human lifetime, it will move in the sky about a quarter of a degree, which is about half the angular diameter of the full moon. So compared to all those other stars that are really far away and not moving much, it's a mover and a shaker, but it's not like you would notice too obviously.
So remember that number 10.3, because I've got a comment from another listener about that. But Jose, congratulations. We're going to send you that lovely Planetary Radio T-shirt, which I saw a couple of people wearing here this evening, as a
They're stylish.
matter of fact, yeah. Although I like the Star Trek T-shirt out there just as much. Thank you so much. Live long and prosper out there. So here's another one. This just happens to be a fellow countryman of Jose. It's Felipe Campello, who is also in Brazil, who said that 10.3 seconds of arc per year, he said this would amount to approximately 0.5% of the angular diameter of the moon. Also, in a bit of weird anatomical numerology, the number 10.3 is also the length in meters of the arm you would have to grow if you wanted to hold a hair at arm's length to cover 1 arc second of sky. Is he pulling our leg or arm here?
Well, I was going to say that, but...
But I got there first.
First, a minor correction. The 10.3 arc seconds is not the angular diameter of the moon. It's if you multiply that out over human lifetime scale years.
Ah, okay.
But then, yes, I haven't done that calculation myself, oddly enough.
Can I? I'll give you a couple more here.
Please do.
Stephen Coulter, another regular who's down in Australia, one of our Down Under listeners, he said that because of this motion, in approximately 10,000 years, Barnard's star will be at approximately the same distance as the Alpha Centauri system. So can we surmise from that Barnard's star is rushing to be our closest neighbor?
Yeah. Barnard is actually the B in BFF. Little known fact.
We got a bunch of nicknames for Barnard's star, too.
Well, sure, why wouldn't you?
Well, but apparently these are legit. Magdalena Krich of Poland and Dan Campbell in Georgia, among others, told us it's also known as the Arrow, the Runaway Star. I like this one, the Greyhound of the Skies.
I got nothing.
No, somebody must have come up with that because we had several people who did that. All right, you have a question for the listeners at home for next week.
All right, so for the listeners, no yelling out the answer. How many orbiters has NASA sent or tried to send to Mars?
So successful or unsuccessful?
How many were successful? How many successfully achieved orbit in working condition, and how many total were sent?
All right.
All right, go to planetary.org/radio contest to get us your entry by when, Matt?
By the 30th of September, Tuesday the 30th at 8 a.m. Pacific time to enter this contest and win yourself one of those version 2.1 Planetary Radio t-shirts. Now we get to the part of the game that we get to play here with the folks at the Crawford Family Forum. Now the bad news here is my mea culpa. I forgot to pick up the shirts. So there's nothing for Bruce to throw out tonight. So if you win, we're going to have to pantomime it, which means that Bruce is going to make some of the most accurate throws this evening, probably the most in his entire career. So play along with us, and we will once again, you'll need to raise your hand, don't shout out the answer, and somebody will run over with a microphone. And we'll start with this question that Bruce is about to give us.
All right, to get your pantomime thrown t-shirt, what 3 orbiters are currently... what 4 orbiters are currently active at Mars? What 4 functioning orbiters?
4 orbiters, raise your hand if you want to give it a shot. Right over here, gentleman in the white shirt. Hi there, sir, what's your name?
The Express, Odyssey, and MAven.
That is correct. So Mars Reconnaissance Orbiter, Mars Odyssey,
Congratulations.
MAven.
Oh, God.
Wait, what?
We've got pins.
I brought this today.
This is Jennifer Vaughn, the Chief Operating Officer of the Planetary Society, who is
purveyor of pins.
You want to throw pins
Children
at the audience?
with
I don't know. They're kind of
pins.
sharp. Come on up here and we'll give you your pin. Congratulations.
I can throw 'em.
Wait till the end of the show and then we'll get that from you. Bruce, another one.
All right. What is the first name of the MAven principal investigator?
It's a trick question. How about way over there? I happen to know that is Liam Kennedy, who does some video stuff for us. Go ahead, Liam.
Hi. Would it be Richard?
That is incorrect.
Oh, it is incorrect. There you go.
Richard would be the
You're going to
first.
be even more embarrassed when you hear the correct name. Right over here. Hi, we're going to...
Hi. Bruce?
Yes!
What a coincidence.
Bruce Chakosky, principal investigator. Oh, you know what I forgot to do?
Here we go. This is not really working for the radio audience. The wind up in the pitch, and there it is. Oh, he hit her in the eye.
Oh, God. We should have liability things for virtual pretend things.
Let's do one or two more.
All right. What molecule is the major constituent of the Mars atmosphere, making up about 95% of it?
Most of the Mars atmosphere is made of this material. This, I'll even say compound, way over here on the side. Hi, what's your name, sir?
Greg? Is it carbon dioxide?
Yeah.
Well, you scared us for a moment. Bravo, we got another winner out
Dramatic pause.
There was the sound.
Yeah, that was beautiful.
Okay, one more. This will be the last one of the evening.
Right. What was the first Mars orbiter? What was the first Mars orbiter?
It was mentioned during this evening's show. We got a
Check
few
your
other people
notes.
who have not had their hands up before. Let's see who we get to first. Hi there. What's your name, sir?
Hi, I'm Jeff Perry. Is it Mariner?
Which one?
Mariner 1.
That is incorrect.
Another shot. Over there on the side. And the radio audience. Well, this will all be really snappy for the
I'll give it a shot. Mariner 9.
That is correct.
All right.
Well played, sir. And here is your T-shirt. Oh, nice catch.
Good catch. All right. Bruce, I think we're done.
All right, everybody. Go out there, look up in the night sky, and think about exit signs that lead you to your destination. Thank you, and good night.
And that is a sure sign that we have reached the end of the What's Up segment with the Director of Science and Technology for the Planetary Society, Dr. Bruce Betts. And that is it for this evening's Planetary Radio Live celebration of MAven's arrival at Mars. Planetary Radio will be back next week with Congressman Lamar Smith of Texas. He is the chair of the House Space Science and Technology Committee, and I can tell you it's a great conversation. It's already in the can. Our next live show will find us in beautiful Toronto, Ontario on Wednesday, October 1st. You can join Bill Nye and me in person or for the live webcast from the University of Toronto as the Canadian Space Agency astronaut Jeremy Hansen and other special guests help us to celebrate Canada's accomplishments on the final frontier. There are details at planetary.org. Back here in Pasadena, we want to thank KPCC, Southern California Public Radio, for once again hosting us at the Crawford Family Forum. By the way, I'll be back here once again in the forum on Saturday, October 4th, for another edition of KPCC's Next Science People Tomorrow series, this time featuring scientists who are also accomplished artists and musicians. Janice Wachi-Hurst is the forum producer. David McKeever is the technical director and our recording engineer this evening. Also assisting us from KPCC tonight were Liz Brown, Haley Waters, and Valentino Rivera. Out front in the lobby was the Planetary Society's Whitney Pratts, and Planetary Society Digital Marketing Manager Karen Hames has been live tweeting all evening. Martians can only hope that they will one day be as cute and cuddly as KPCC's managing producer of forum programs and live events, John Cohn. I'm Matt Kaplan of the Planetary Society, wishing you a good night and clear skies.